Okay, guys. So we are ready to start 2-2. Okay, and before we start 2-2, this video is filmed before we even started chapter 1. It's just so sometimes the order that I do things in here is going to be way behind what we do in class. So we're going to start by just drawing a normal model. So what I would like you to do is I would like you to pause your video and I'd like you to draw a normal model. Okay, very important. We're going to use it throughout the course, and really understanding it and what the numbers mean is what's really important. Okay, so please, again, I can't control you. Okay, you guys are watching this. Some of you might be watching it while you watch TV. You know, it is what it is. I have to try to maximize our time together. So the best way right now that I know of doing this stuff is by having you guys watch these videos, and then I can help you do the problems. So I'm hoping that you're pausing this video, but I don't know. I don't know what you're doing. Okay. So for those of you that paused the video, planes over here, it starts off in the runway, it goes up and it comes down, and that is a little bell curve or a normal model. So what do? We cut off the tails, we put a line in the middle, and then we split the uprights. Okay, now for now I'm going to put these little bars in here. Now in a regular problem, when we get going with this stuff, you won't have to do this. Okay, but I do want to do it for now so that you guys start to see these numbers, you start to make connections with these numbers, and we start to figure out what they mean. Okay, and so the first one is going to be percentile, and then we have a z-score, and then we have a data value. I'm going to do the same thing over here, percentile, z-score, data value. Okay, now here is the 50% mark. Okay, that's the 50th percentile. We know that when we did our empirical rule, okay, mean 68. So from here to here is 68%. So if that is 68% and 50 is in the middle of that, that means that there's 34% here and here. And there's 34% here and here. Okay, so if there's 34%, the number that goes here is a 16. I don't know why I wrote those lines there. You don't need those lines there. It kind of bothers me. And that's 84. Now, after 68, so we do mean, we do 68, and then we do 95. Okay, we do 95. So from here to there is 95. So I have to find out what's left. Well, the calculator will do that for you. So I go over here and I type in 95 minus 68, and that's 27. And if you divide that by 2, you get 13.5. So 84 plus 13.5 is 97.5. And then 16 minus 13.5 is going to be 2.5. Okay? And that's really as far as that we need to go. Okay? For this is a z-score of 0, this is a positive 1, this is a negative 1, this is a positive 2, this is a negative 2, and a data value will change based on whatever the problem is. Okay? So this is a normal curve. Okay? It's symmetric, it's single peaked, and it's bell-shaped. Okay, this is completely, any normal curve is completely described by the mean and the standard deviation. Now, we don't know what the mean is here. We don't. Okay, we haven't talked about that yet in this particular problem. I just want to draw a normal model. So the mean is located at the center, and the same as the median. So when you have something that is single-peaked and symmetric, your mean and median are going to be right in the middle. Okay, so whatever your data value is there, let's just say that for this problem, my mean is 20 and my standard deviation is 5, we'll say. Okay, So that means that my data value here is 20. I go up one standard deviation, that's going to be 25. I go up another one, that's going to be 30. I go down one, this is going to be 15. I go down another one, this is going to be 10. So now I at least have some data values there. Okay, remember, z-score, positive z-scores, these are standard deviations above the mean. Negative z-scores, standard deviations below the mean. So it talks a little bit about this stuff. I'd like you to draw a normal model right there so you have it. Okay. Talks about normal distribution, SAT test, IQ tests, other things that they use for that. So here's our 68, 95, 99.7. And we've talked about this already because we did this when we did the squirrels in the, probably in a live session, I would say that I've done that with you. Okay. So 68% of the observations here fall here. 95 fall there. And then I guess I could put another one here if I wanted to. I could go here and say that's going to be 99.7% is all the way there. So it tells you that anything outside of positive 3 or negative 3 standard deviations is very rare. Very rare. Well, how often does it happen? 0.3% of the time. Okay, so when we talk about z-scores over 3, that's just very hard to believe, okay? Because it's a very small chance of happening. So all the models are wrong. This is just an approximation. There's nothing that's going to be exact with this stuff. We do the best that we can. It's an approximation. They're approximately normal. You don't ever say a graph is normal. You say it's approximately normal, okay? So up here it says the standard normal distribution. Let me get that out of the way. It's distracting. So the standard normal distribution is the normal distribution when the mean is 0 and the standard deviation is 1. And we've talked about that. So when you're using your notation for something that is approximately normal, you can represent that with a capital N and then an ordered pair where the first number in your ordered pair is the mean and the second one is the standard deviation. So for the problem that we had right here, we could describe this distribution by saying n 20, 5. This is understood to be the mean, and this is understood to be the standard deviation. We will get to a point, okay? We will get to a point where we're going to talk about these. And we're going to talk about this notation. So this model is really good for finding values that are nice, even whole numbers, okay? I shouldn't say even, but whole numbers, okay? 0, 1, and 2, and then 0, -1, and -2. But we know that it's not always going to work out even like that, or quote even, where we have these whole numbers as z-scores. So we have to find another way, and we've already done this with the what do we want to call it? Oh boy, the flowchart. Okay, we've already done some of this work with a flowchart, but we're going to continue here. Okay, so I want to go over what's called the standard normal table. So I don't do a lot with the normal table. The table you can use, instead of using your calculator, you can use table A that is located in the back of your textbook. You will have this on the actual exam. It's part of like the formula sheet. And if you look, you just flip from the back, you flip a few pages and you'll see here's your standard normal probabilities. So you could either use your calculator or use this table. To me, it's much easier and much faster to use the calculator, so that's what we do. But I do want to show you how to do this. So it says find the proportion of observations from the standard normal distribution, that colon shouldn't be there, or semicolon, that are less than 0.81. Okay, so I open this up, okay, and I want to find less than 0.81. Well, all of these z-scores are negative, so what I have to do is I have to come over here and look at a positive z-score. Okay, and this is always, as it shows in the picture at the top, the table for z is the area under the curve to the left of z. So if I want the left of 0.81, I go on this side and I find 0.8, and then I go over and I hit 0.8, and that would be 0.81. that's going to be 0.7910. Okay, now when we do it on a calculator, it's probably not going to be exactly that. Okay, these are all approximations. Let's do it. So let's see. Let's see if you guys tell me if this is what I do. So I'm going to do second vars for dister. I'm going to do norm CDF. And then I'm going to do negative 999. And I'm going to go to, what did they say it was? 0.81. And it should be close to what we had there. 0.7910. Okay, so we get the same thing with the calculator. And again, we do this because you want to pick up everything. Now let's just look, for the heck of it. Let's look. Second dister, if I did norm CDF -3, I tell you that there's not many observations that fall outside of z-scores from -3 to 3. So let's look at what would happen if I just put that. Our answer is right above that. You know, it would round to the same number, but we always just use negative 999 because that's going to get everything, absolutely everything. Okay, I've never heard of a z-score lower than negative 900. I'd never heard of it. Okay, so we use negative 999 and we use positive 999. But that's how you use table A. Okay, so I did want to go over that with you. If you guys have questions on that, I'll certainly answer them for you. But I think it's much more important that we know how to use the calculator and we're good with using the calculator. So now we have to figure out finding the area to the right. So let's say I had a normal model drawn. It's always helpful to give you a frame of reference by drawing a little normal model for this problem. We want to find, so I know that that's probably lopsided, but that's 0. I cut off my tails, I split my uprights, and I'm just talking about z-scores now, okay? Just talking about z-scores. That's a +1, that's a +2, that's a -1, that's a -2. I want to find the area to the right of -1.78. Well, -1.78 would probably come in here somewhere, and I want to find to the right. Well, if I use table A or if I use the calculator, this gives me the area to the left. So if I were to type this in and I go norm CDF, the normal cumulative density function, that's what that stands for, and I did negative 999 to negative 1.78, that should be a relatively small number. And that's going to be the area here that I'm going to leave as striped. So I do that. Okay, I do that. I do second dister, and I go to norm CDF, and I do negative 999 to negative 1.78. And that's going to give me 0.038. So that's 0.038. But that's not what it asked for. It asked for this. Okay, and so the way that I find that, we know that the area under this normal model is equal to 1. So if I want to find the area to the right, I would do 1 minus 0.038. Some of you guys probably already figured that out. 1 minus 0.038, and I get 0.962. So the answer to that problem is 0.962. So if you're finding the area to the right, you use your calculator, you find out what the area to the left is, and then whatever that area is, you subtract from 1. Okay? So now they give me one like this. And they say, find the area between these two numbers. So again, I'm going to draw this out. Okay. And you know what? Let me see. I think I can still fit it here because I want to look up here. So it's always good to have that normal model and have this knowledge because then it tells you if your answer is reasonable. Let's look over here. So we said that our answer here was, if I was finding this part, just this part of this answer, we said is about 4%. Let's see if that makes sense. Negative 1.78. Here is negative 1, here's negative 2. Negative 1.78 is somewhere here, okay? This is 2.5. Does that make sense that it's going to be about 4? To me it does. To me it does, okay? So we're going to do the same thing here. So here I'm going to have, here's 0. Okay, I cut off my tails, I split my uprights. That's 0, that's 1, that's 2, that's -1, that's -2. They want to go from -0.58, so that's going to be somewhere in here. It doesn't have to be exact. This picture is just to give us an idea. And 1.79, so it's going to go from there to there. I want to find this area. Well, we can use this as a guide. So it looks like it's going to be somewhere in here, maybe somewhere in the 30s. If I'm looking at a percentile, somewhere in the 30s. And then I'm going to somewhere over here, something in the 90s. So our answer should be about 60-ish. That's a guess, okay? But that's why we have a calculator. Calculator is going to tell us. So I do second vars for dister, distributions. And then I go from -0.58, my z-score on the left, and I'm going to positive 1.79, my z-score on the right. Again, we're talking about z-scores, so when you have a z-score, the mean of your z-scores is 0. The standard deviation of your z-scores is 1. And that comes from this. That comes from my chart. Here it is. Here it is, 0, and then my standard deviation is 1, okay? And I get 0.68. Well, I thought it was 60-ish, so I think that I'm going to be in good shape, 0.682. Okay, and always go to 3 decimal places. So let's look at what these directions say. Normal distribution calculations, 4-step process, express the problem in terms of the variable. Okay, draw a picture and shade the area of interest. I've been trying to do that, and then you do your calculations. Standardize X to restate the problem. Write your conclusion. Okay, so here we go. Let's do a problem. So for these, I will probably have you guys pause the video, but let me read it to you first. So in the 2008 Wimbledon tennis tournament, Rafael Nadal averaged 115 miles per hour on his first serves. Assume, that's fast, assume that the distribution of his first serve speeds is normal with a mean of 115 miles per hour and a standard deviation of 6. About what proportion of his first serves would you expect to exceed 120 miles per hour? Well, let's draw a picture, a really quick normal model here. Okay, so I'm going to put my middle, I'm going to cut off my tails, I'm going to split the uprights, and this time, instead of putting z-scores in, I'm going to put the data values in. So the mean is 115, so I put 115 here. Now I've got to figure out what goes there and what goes there, and that's going up z-scores. Going up a z-score or going down a z-score is going up a standard deviation or going down a standard deviation. The standard deviation is 6. So this would be 121, and this is going to be 127. And then if I go down 1, this is going to be 109, and this is going to be 103. Well, they want to find out which ones we would expect to be bigger than 120. Well, we know our 120 is right over here, and I want to find that. Well, let's look. One standard deviation above is 84. So what would I expect? I'd expect it's going to be about 16%, somewhere in 16% area. So let's go through and let's find that. But we're going to do the math out. Okay, so I want to find a z-score. So my formula is data value minus the mean divided by standard deviation. My data value is what, 120? So I go 120 minus 115 divided by 6. Okay, so I'm going to get 5 over 6, and 5 over 6 is going to be, I think, 0.875. 5 divided by 6, no, 0.833. 0.833. So again, I want this part. Remember how we have to do that. We have to do norm CDF, okay, and my left z-score is going to be 0.833. So I'm going to do second dister 0.833, and then I'm going to go to 999, and I get 20%. So norm CDF, what do we say it was? From 0.833 to 999. We want to do some notation. That's my z to the left. That's my z to the right. We said it was going to be about 16, right? That would be for 121. It's a little bit bigger. It's at 120, so it makes sense that it's going to be approximately 0.202. Now I also could have done